Swiss mountains. Then I started to do my chemistry studies at ETH in Zurich, ETH in Zurich. That's a chemistry building, it's an old chemistry building. I didn't like the studies too much, they were very boring. And we had to memorize without understanding what is going on. But that's not what I expected from chemistry. Anyway, that's where I did my undergraduate study. During that time also I had my second employment in Basel. I mean, you know, Basel is the chemical city of Switzerland. All the chemical companies are in Basel. So there I worked my second apprenticeship. And here I also was writing my very first paper. So already during the studies I could publish, and I was very fortunate that I had a good group to collaborate with here at ETH. And then I had to start my PhD thesis. I finished my studies, and then the PhD came. And I went to a potential thesis advisor, Professor Günther. He was the professor of physical chemistry, and asked him, what shall I write my thesis on? And he inspired me. He inspired me with Genzano and with Campari, with spiritual things, so that's the inspiration. And he told me do NMR. And I asked him what that mean. I never heard this abbreviation NMR. And he explained it to me. I mean, you see, that was my reaction here. What means NMR? I couldn't even understand this abbreviation. So I tell you now what he told me. He said it has something to do with the molecules. And molecules consist of atoms, so let us pick out one of these atoms and blow it up, and we find in the center an atomic nucleus. Let us blow up the atomic nucleus and look at it more closely. And you see that it has actually a magnetic moment built in. That's a small magnet with a north pole and the south pole, and at the same time it's rotating about its own axis. It has an angular momentum. And he told me, Professor Günther, this is being called the nuclear spin. That's a spin of an atomic nucleus. And he said, this is what we are investigating with NMR. Nuclear magnetic resonance. It has something to do with the nucleus, has something to do with magnetics, it has something to do with resonance. So, he said then, when you apply a magnetic field, then these nuclei start to rotate about the magnetic field. This is a resonance. And they rotate with a particular frequency, which is determined by the magnetic field strength, like that here. Omega is equal to gamma times B0. B0, that's the strength of the magnetic field. So the frequency of rotation is proportional to the magnetic field. And in this way, you can measure the magnetic field strength, the local magnetic field strength within molecules. And he said, that is interesting for chemistry. I didn't know whether it's true or not, but that's what he said. And he said it has been invented by Edward Purcell and Felix Bloch. And Felix Bloch, he graduated at the same school at ETH in Zurich. So follow in his footsteps, he told me. And I tried. So he also performed an experiment with a hula hoop ring. That's the spinning of the nuclei, but of course I felt it's a little bit silly what he was doing, and I would much more have liked an Indian dancer, belly dancer, doing this belly dancing here with all her possible motions, having many nuclei rotating at the same time. That would have excited me, but he couldn't do that so well. Anyway, he told me then, when such a belly dancer has now several rings on her body, some corresponding to the methyl group in alcohol, some corresponding to the methylene group, some to the hydrogen atom of the OH group, then they all have different resonance frequencies. They process with different frequencies, and if you record these frequencies, you get an NMR, a nuclear magnetic resonance spectrum. That was the explanation which he gave me. And yeah, I thought if you find a nice belly dance, I mean, that could really be interesting. And then he said, he has a co-worker who is just building an NMR spectrometer, and I could possibly help him building this NMR machine, and that's Hans Primas. And he's sitting here in front of a scope, just building a machine. And I helped him finishing his machine which he was building. And you see here the result. This here is a magnet. The magnet you need, I told you before, and then you get some signals out, and these signals are being amplified here by this electronics. So that's a typical NMR spectrometer. A magnet and some electronics. But this beautiful little instrument, it didn't perform well. As poorly as me when I wanted to start to speak. I mean, everybody has his problems, even NMR spectrometers. And you see, the recording of a spectrum was very, very, very slow. You had to wait for hours till the snail was crawling through the spectrum, recording one line after the other one. Of course, today we don't have time, we want to have it fast and instantaneously, and one couldn't do it. So I was very disappointed. And I thought, I'm on the wrong track. We cannot use this kind of machinery. But then we had a brilliant idea. And the brilliant idea was to commercialize this. At least to make money out of it. If it's useless, we could at least sell it. And you know, on the market there are so many useless electronic instruments around, and you go on to buy them and spend your precious money for this nonsense, these toys. And we just wanted to add one more toy to the market. And we went to a company which is called Lecture3.mp4, and they said, we are building all measurement instruments. And so this is this company, and Günther and Primas, they went to this company. They found Dr. Wegmann sitting at the electron microscope and asked him, Dr. Wegmann, can you also build NMR spectrometers? And he was smoking 7 pipes, and then he said, let's try it. And they tried it. And they tried it and built this little copy of our machine. That's the commercial NMR spectrometer. You see it here in full-blown picture. But it was a flop. It didn't really properly work, and the company went out of business. And we were responsible for that failure. But you know, flops, they offer chances. And the German professor, he heard of that. He bought the company. That was Professor Laukin.